Have you ever pondered what the universe will look like in one Google years? That's a 1 followed by 100 zeros, a number so colossal it's virtually impossible to comprehend. It's far beyond the age of our universe, which is a mere teenager in comparison at around 14 billion years old. This unfathomable number, this Google, is the timeline we're going to explore today. We're going to take a leap of imagination, guided by the principles of physics and cosmology, to envision the possible states of the universe in this distant future. From the death of stars and the reign of black dwarfs to the decay of protons and the end of matter as we know it, even to the bizarre concept of quantum resurrection and the emergence of Boltzmann brains. It's a journey that will stretch your mind beyond its limits. So fasten your seatbelts as we embark on this journey through time and space. First, we need to understand that stars won't last forever. Stars, those twinkling points of light in the night sky, are not eternal. Each star is a crucible, constantly fusing atoms together in a fiery dance that releases an incredible amount of energy. This energy is what makes a star shine. But eventually, the fuel that powers this cosmic ballet will run out. When a star exhausts its nuclear fuel, its fate is determined by its mass. Stars with a mass similar to our sun will swell into red giants, then shed their outer layers to reveal a core of carbon and oxygen. This core, known as a white dwarf, will slowly cool and fade over billions of years. Stars with a greater mass meet a more dramatic end. They explode in a supernova, leaving behind either a neutron star or, if the star is massive enough, a black hole. Neutron stars are incredibly dense. A teaspoon would weigh about 1 billion tons. Black holes, on the other hand, are points in space where gravity is so strong that nothing, not even light, can escape. Fast forward to about 1 trillion years from now, and we enter the black dwarf era. By this time, all the stars in the universe will have exhausted their fuel and turned into white dwarfs. These white dwarfs, over countless eons, will have cooled and faded until they no longer emit any light or heat. They will become black dwarfs, the cold, dark remnants of stars. During the black dwarf era, the universe will be a vastly different place from what we know today. There will be no more starlight, no more galaxies visible in the night sky. The universe will be populated by black dwarfs, neutron stars, and black holes scattered across the vast cosmic sea. The universe will be a dark, cold, and desolate place, but that's just the beginning. The end of the starlight era is not the end of the universe, but the start of a new, unimaginably long chapter in its history. Even the remnants of stars won't last forever. The curtain of eternity draws back to reveal the third act of our cosmic drama: proton decay and the end of matter. Let's delve into the concept of proton decay, a hypothetical prediction made by certain grand unified theories, or GUTs. These theories, as their name suggests, attempt to unify all the fundamental forces of nature into one grand equation. A key prediction of some of these theories is the eventual decay of protons, the building blocks of atomic matter. Imagine, if you will, a proton. This tiny particle, one of countless billions in every atom, has a potential expiry date. These GUTs suggest that protons might not be eternal, but could decay over unimaginably long timescales into more fundamental particles. Now, this isn't a process you'd need to worry about over your morning coffee. Proton decay, if it happens at all, would occur over timescales so vast they make the age of the universe seem like a blink of an eye. We're talking timescales of a Google years. That's a 1 followed by 100 zeros. By this time, it's likely that all matter, the stuff you, me, and everything we know is made of, will have disintegrated into photons and leptons. Photons, particles of light, and leptons, a family of particles including the electron, would then be the primary constituents of the universe. An energy-filled universe, where matter as we know it has ceased to exist. A universe where the building blocks of matter have dissolved into the ether, leaving behind a sea of pure energy. A universe where stars, galaxies, even black holes have become relics of a bygone era. But don't let this bleak picture dishearten you. Even in a universe devoid of matter, things can still happen. Energy, after all, is a dynamic and powerful force. And as we'll see, the universe, even in its twilight years, might still have a few surprises in store. But even in this energy-filled universe, things can still happen. In an infinite amount of time, even the most improbable events become possible. Quantum resurrection and Boltzmann brains are two such events. Quantum resurrection refers to the idea that given enough time, Quantum fluctuations could lead to the spontaneous creation of self-aware entities. Now let's break it down a little. Quantum fluctuations are temporary changes in the amount of energy in a point in space, as allowed by the Heisenberg uncertainty principle. These fluctuations, while seemingly random, are the cornerstone of quantum resurrection. In an infinitely expanding universe, these fluctuations could, theoretically, organize themselves into any possible configuration. This includes the arrangement of atoms that make up a human brain or a self-aware entity. These spontaneously arising entities are what we refer to as Boltzmann brains, named after the physicist Ludwig Boltzmann, who proposed this idea. Boltzmann brains are a fascinating concept, a testament to the sheer power of infinity and quantum mechanics. And they're more than just a theoretical curiosity. They challenge our understanding of the universe and our place within it. If Boltzmann brains are possible, and the universe lasts forever, then it's likely that most self-aware beings in the universe's history will be these spontaneously formed entities. Imagine that for a second. A universe filled with self-aware entities, spontaneously formed from quantum fluctuations. These entities, or Boltzmann brains, could be the last beings to exist in the universe. The future of the universe is truly mind-boggling. We've traversed some of the most profound theories: the inevitable death of stars, the predicted end of matter, and the perplexing concept of Boltzmann brains. Yet these are mere speculations, set against timescales so vast they dwarf human comprehension. While we may never know for certain what will happen in one Googol years, it's fascinating to ponder the possibilities. It reminds us of our place in the universe and the beauty of the unknown.